Assalamu alaikum, sir. My ID is 1900202019. Here is my first machine learning sessional question. The logistic regression. Here is the questions about the one questions, and the answer is um, here is the answer is first. We're just importing the necessary libraries like pandas, numpy, and we must have to load up the data set from sklearn. So after that, we just load the wine data set from sklearn. Here we just load the wine data set, and this df means data frame, and df target wine.target means this terminal lines add a new column called target, and the data frame assigns the target variable from the wine dataset. And the DF had the screen displays the few rows of the data frame and showing a brief preview of the data with features and corresponding target values. After the third step, we split the data set into a training set and a training set and a testing set. Here we just first we just drop the target and exit one. Then it's a new data frame X by dropping the target column from the original data frame. And the Y is equal to DF target means this means basically it's a panda series by continuing the target levels by extracting the target column from the original data frame. And after that, in the fourth step, we to train a logistic regression. To train a logistic regression model on the training set and make prediction on the testing set. Here we test the train, where we test the trained we use for train the logistic regression model, predict the class level for the testing data set, and that displays the array of predicted class levels on the screen. And in the fifth step, we just compute the confusion matrix, and here we compute the precision recall F1. Basically, precision is a matrix that measures the proportion of true positive predictions out of all positive prediction made by the model. And the recall means this is also a matrix that measures the proportion of true positive prediction out of all actual positive samples in the data set. And F1 is a single metric that combines the both precision and recall. And here we just call the precision to see the output, recall, and F1. My next question is subnet vector machines SVM. Here is the questions. And here is the answer. We did the same thing with first. We just importing the necessary libraries here in the first step, and in the second step, we just load the data set from sklearn and just display some rows by df.head. And in the third step, we just split the data set into a training set and a testing set, and by 70 by 30 ratio. And in the fourth step, we train an SVM model on the training set. Basically, is SVM. These two lines means these two lines represent a training of a subnet vector machine model with a linear kernel and regularization parameters set to 1. And in the fifth step, make prediction on the testing set. Just make prediction on the testing set and compute the accuracy of our model. Here is the we can see the accuracy. And in the last step, we just plot confusion matrix and parameters to interpret the results. This codes basically this codes generates and displays a heat map. Those codes displays a heat map representation of confusion matrix for evaluating the performance of a classification model on the test dataset. And here is the you can see the heat map confusion matrix, and here is the predicted level. Here is our last question, K-means clustering. There is the question, and here is the answer. Here we first same thing. We first importing the necessary libraries, and on the second step, we generate a synthetic. We generate this synthetic data set using scalan data set make box function with 500 samples, two features, and 4 centers. In the third step, we determine the optimal number. We determine the optimal number of cluster K using the simple method. This score is equal to -1, this K is equal to 0. And here we created a loop. This code basically provided is performing loop that iterates over different values of K from 2 to 10, 10 from 2 to 10. And K represents the number of clusters in the K-means algorithm. Here we just apply K-means clustering. Here we just apply K-means clustering to the dataset with the optimal number of cluster levels will K-means the last step we just visualize the cluster into this scatter plot. Yeah, basically those lines, those code is creating a scatter plot to visualize the results of the K-means clustering on the dataset X. There we can see plot figure size, basics. This means it creates a new figure with a specific size of 8 inches, 8 inches and in width and 6 inches in height. And here we just C1 the scatter plot function to create. Here is the C1 scatter plot function to create a scatter plot with X and x-axis on the x-axis and the second feature on the y-axis. Just what actually this command, this is the level of x and y-axis with appropriate names and better visualization features one. Those are levels and title of them. Title of this K-means first time. But this adds a legend to the plot to distinguish data points and cluster centers. And after in the final for this plot, this command displays the plot on the screen. You can see the plot on the screen. There is my answers. Answer of the 3 questions. Machine learning. Thank you, Sam. Assalamu alaikum.